Have you ever wondered how researchers summarize and make sense of large amounts of data? Whether it's predicting market trends, analyzing medical studies, or understanding social behavior, descriptive statistics play a crucial role in research. In this session, we will cover fundamental concepts such as mean, median, mode, standard deviation, correlation, and regression models. By the end of this video, you will have a solid grasp of how these statistical tools contribute to sound data analysis in research. Let's begin by understanding what descriptive statistics are and why they are essential in research methodology. Descriptive statistics are brief informative coefficients that summarize a particular data set, which can be either an illustration of the entire population or a sample of a population. Descriptive statistics focus on the creation and development of certain indices from the raw data. The survey of research data is summarized using a variety of statistical metrics, the most crucial of which are central tendency or statistical averages, dispersion, correlation, and regression. Let's start with the measure of central tendency. One of the most common ways to summarize data is by using the mean. Mean is the value obtained by dividing the sum of the values of all different items in a series by the total number of items, which is also known as arithmetic average. We can figure it out as follows, where x bar is the symbol we use for mean, xi is the value of the item, and n is the total number. Limitation of mean are it's unduly affected by extreme items, may not coincide with the actual value of an item in a series, lead to wrong impressions, particularly when the item values are not given with the average. Now, median is the value of the center item in a series arranged in ascending or descending order of magnitude. It splits the series in half, with all items in one half having values below the median and all items in the other half having values above the median. We can figure it out as follows. Median equal value of n plus 1 by 2th item. Median is not useful where items need to be assigned relative importance and weights. It's not frequently used in sampling statistics. The value that occurs most frequently in a dataset is called the mode. It can be used to determine which observation is most frequently made and is a measure of central tendency. The mode is unaffected by extreme values. In contrast to the mean, if every value appears with the same frequency, a dataset may have one mode, unimodal, multiple modes, bimodal, or multimodal, or no mode at all. There are certain limitations of mode as well. For example, it's not amenable to algebraic treatment and sometimes remains indeterminate when we have two or more model values in a series. It's considered unsuitable in cases where we want to give relative importance to items under consideration. These are less common measures like geometric and harmonic mean. Geometric mean is the nth root of the product of n values used to calculate average rates of growth or ratios in a given series. The most frequently used application of this average is in the determination of average percent of change. It's often used in the preparation of index numbers or when we deal in ratios. On the other hand, harmonic mean is the reciprocal of the arithmetic mean of the reciprocals of a set of values, often used to averaging rates or ratios of values of items of a series. Harmonic mean has limited application, particularly in cases where time and rate are involved. The harmonic mean gives largest weight to the smallest item and smallest weight to the largest item. Now let's talk about measures of dispersion. An average fails to give any idea with the scatter of the value of items of a variable in the series around the true value of the average. In order to measure this scatter, statistical devices called measures of dispersion are calculated. The simplest measure is the range, which is the difference between the maximum and minimum values in a dataset showing its spread or dispersion. The advantage of range is that it gives an idea of the variability very quickly. Limitations are it can be affected very greatly by fluctuations of sampling. Its value is never stable, being used on only two values of the variable. Range equal highest value of an item in the series minus lowest value of an item in the series. A better alternative is the mean deviation, which is the average of the absolute differences between each data point and the mean or median of the dataset. It measures dispersion and variability. In calculating mean deviation, we ignore the minus sign of deviations while taking their total for obtaining the mean deviation. We can obtain is as following, where delta equal mean deviation and equal number of items, x is the ith value of x. The standard deviation and variance are two of the most important measures of dispersion. The variance calculates the average squared a deviation from the mean, while the standard deviation is simply its square root. These measures tell us how much individual data points deviate from the average. Higher standard deviation measures the data is more spread out, while a lower standard deviation indicates more consistency. The coefficient of standard deviation, a relative measure that is frequently used to compare with similar measures of other series, is the amount that results from dividing the standard deviation by the arithmetic average of the series. It's used mostly in research studies and is regarded as a very satisfactory measure of dispersion in a series. It's amenable to mathematical manipulation because the algebraic signs are not ignored in this calculation. It's less affected by fluctuations of sampling. Measures of correlation help us understand relationships between variables. Cross-tabulation is a method for analyzing correlations between nominal data and involves categorizing variables and investigating interactions. These interactions might be reciprocal, but variables influence one another. Symmetrical variables Symmetrical variables vary together without one triggering the other, or asymmetrical one variable causes the other. A two-way table is used as a starting point for the analysis, and conditional linkages can be revealed by adding a third variable. For ordinal, interval, or ratio data, different approaches are used because cross-tabulation is less effective despite its usefulness. Spearman's coefficient of correlation is a technique for assessing the degree of correlation between two variables in ordinal data where the variables are ranked according to their respective values. The primary goal of this coefficient is to determine the degree to which the two sets of rankings are similar to different. Pearson's coefficient of correlation is the coefficient assumes that there is a linear relationship between two variables, that one is independent and the other is dependent, and that both variables have many independent causes resulting in a normal distribution. Pearson's coefficient of correlation assesses the degree and direction of relationship between two variables. The value of varies from -1 to +1. R equals 0 indicates no association. R equal +1 shows perfect positive correlation. R equal -1 indicates perfect negative correlation, implying that the changes in the independent variable entirely explains changes in the dependent variable. A value of near ±1 suggests a greater correlation. Regression modeling is a statistical technique for determining the relationship between the dependent variable and one or more independent variables. It attempts to predict the value of the dependent variable using the values of the independent variables by fitting an equation of mathematics regression equation to the data. Multiple regression models include more than two independent variables to test the proposed relationship. The key methods used are ordinary least squares (OLS) and maximum likelihood method (MLM), which are essential for empirical research. Functional forms of regression model are as follows. First, we have the linear model, which follows the form y equal alpha plus beta x plus u. This is the simplest and most commonly used regression model, assuming a straight line relationship between the independent and dependent variables. This model is linear in both parameters and variables and can be estimated using the ordinary least squares or LS method. Next is the log linear model, expressed as y equal alpha x to the power beta into e to the power u. This is useful when the rate of change in y depends on x in a multiplicative way, often applied in economic and financial data analysis. In a log linear regression model, a change in the log of a variable represents a proportional change. The semilog model represented as log y equal alpha plus beta t plus u is used when the dependent variable grows exponentially for time, such as in population growth or stock prices. In a semilog model, the dependent variable is in logarithmic form, whereas the independent variable time is in absolute numbers. Finally, the reciprocal model takes the form y equal alpha plus beta into 1 by x plus u. This model is used when the dependent variable is inversely related to the independent variable, meaning as x increases, y decreases at a decreasing rate. This model can be used to analyze the association between per capita GNP and child mortality. Infant mortality rates are projected to reduce as per capita GNP rises, but they can't fall on their own if per capita GNP rises indefinitely. Today, We explored the fundamental concepts of descriptive statistics, including measures of central tendency, dispersion, correlation, and regression models. These tools help researchers summarize and interpret data effectively, providing valuable insights into patterns and relationships. I encourage you to apply these concepts in your research projects and practice analyzing real-world data. The more you engage with statistics, the more confident you will become in using them effectively. Thank you for joining the session. If you have any question or need further clarification, feel free to ask in the comment section. If you want more sessions like this, like, comment, and subscribe my channel. Keep exploring, keep learning, and I will see you in the next session.